Okay, this is part 2 of week 3. Alright, without further ado, this is about quadratic equations, and I think this is number 16. Alright, so this is the problem. We are going to solve this quadratic equation by factoring. And alright, so we need to remember how to factor, but before we do that, let me show you the equation. This equation is 5m squared plus 21m plus 22 equals to 0. And the solution is as follows. The first thing we need to do is actually factor it, right? The equation or the expression before the equals 0 is going to be written as two factors, as two binomial factors, because this is 5m squared. The first term is 5m squared. So the first term will have 5m, and then the second term will start with m, and that will give you the 5m squared. Now, the 22, don't worry about the 21m right now, but take a look at the 22. The 22 is the product of two numbers. Now, we are missing those two numbers here and here, and when you multiply those two numbers, you should get 22. And there's actually only two factors of 22, 2 and 11. There's only two factors because 11 is a prime factor and 2 is a prime factor. There's no other alternative. So the factors will be 2 and 11. The question will be which one takes 11, which one takes 2. Alright, there will be a plus here and a plus here. And this will be 11 and this will be 2. Now we can verify this, that this is correct. Now if you have to find out whether that's correct or not, let me see the foiling of this. So you multiply 5m times m, that gives you 5m squared. You do the outer, that would be 2 times 5m, and that would give you 10m. If you go the inner, gives you 11m, so you will have plus 11m. And then the last two terms, or the last term is last, 11 times 2, that'll be 22. Now if you do the combination is 10m and 11m, you actually get 21. Alright, so this is correct. This factoring right here is correct. And to find the answers, we need to find the values of m. Alright, so this is a product. 5m plus 11 times m plus 2 equals to 0. So because of the product is 0, we know that 5m plus 11 could be 0. And we also know that m plus 2 could be 0. Right? We're going to do each one at a time. Let's do the second one first. You subtract 2, you subtract 2, that gives you m equals minus 2. Alright, so that's one of the solutions. M equals minus 2. The other one is found by looking at this equation. 5m plus 11 equals to 0. You subtract 11, subtract 11, so you get 5m equals minus 11. You divide by 5, you divide by 5, and the answer gives you is m equals minus 11 over 5. Alright, this is a little cramped here, but this is the other solution. M equals minus 11 over 5, and m equals minus 2. Alright, let's continue. The second problem, this would be, I think, number 17. This is a much easier problem. It is x squared equals 49. And you can do it a couple of different ways. One way is to find the square root of both sides. And alright, so let's find the square root on both sides. The square root of 49 is 7. The square root of x squared gives you x. Now because positive 7, when you square it, you get 49. But also when you square a negative number, you actually get 49. So the answers to this equation is x equals plus 7 and x equals minus 7. Another solution, another example rather, for example 18. Let's do x squared equals 25. you'll have to find the values of x such that when you square, you get 25. And of course, 1 will be 5, right? So x will be 5. And another one will be minus 5 squared is 25, because the square of a positive is positive, but the square of a negative is also positive, right? So the answer will be plus or minus 5. And just one other example, x squared equals 17. We are going to do this by finding the square root, and if you find the square root on the x squared, you just get x. The square root of 17. The square root of 17 doesn't give you an integer, so you have to do the square root of 17. Just leave it like that. Just like on the previous one, one will be plus, and the other one will be minus, right? All right, let's go and do the next kind, which is actually very similar to this one. Number 20. So this one is use the square root property, or it's slightly more complicated. All right, so it is kind of like the previous problems. We are going to find the square root on both sides, and the square root of 23. Well, the square root of 23, right? And we do this because 23 is not a perfect square. If you find the square root of 23, you don't get an integer, right? For example, 16 is a perfect square, so the square root of 16 is 4, but this is the square root of 23. It doesn't give you an integer, but it has a plus and a minus. So we just found the square root of 23 on the right hand side, and if you do the square root on the left side, the square here is going to cancel. So the only thing you get is 2x minus 5. Now, one way to do this is as follows. All right, if you just consider the plus, it would be plus the square root of 23. If you consider just the minus, you actually get 2x minus 5 equals minus the square root of 23. We have to solve it, right? So you add 5, so that gives you 2x equals, if you add 5 and the square root of 23, well, it's 5 plus the square root of 23. And then we are going to divide by 2. All right, so if you divide by 2, you get x equals 5 plus the square root of 3. Where did that come from? Sorry, the square root of 23. The square root of 23 divided by 2. If you did the same for this one, you actually get 5 minus the square root of 23 divided by 2. Now that's perfectly alright if you leave them like this. You actually have two solutions, right? 5 plus the square root of 23 divided by 2, and 5 minus the square root of 23 divided by 2. But you can actually solve the problem by saying this is two solutions. You're all going to divide by 2. 1 is 5. You can have plus and minus the square root of 23. So either one is correct. This is correct, and that gives you two solutions, right? And one of the solutions is like this one, and the other one solution is like this one. All right, let me erase those balloons. They don't look right. All right, so that's number 20. I'm going to the next one. 21. And this is the same, except we have the square root of a negative number. So this is x plus 4 square equals minus 16. Now we are going to find the square root on both sides the same way, right? So the square root on the left side cancels the square, and the only thing you get is x plus 4. If you find the square root of on the right hand side, you will have the square root of minus 16. Now this is weird, right? Because you are going to get an I. We'll see that in a minute. And don't forget the plus and the minus. Whenever you find the square root of a number, like 16, for example, you have square root of 16 and then plus or minus. Even though this is negative 16, you do the same, right? The square root of minus 16 and then the plus and the minus. Now, the square root of minus 16, let me do this separately, could be simplified, or it is going to be simplified as follows. You can actually do 16 times minus 1. That's terribly trivial, right? That's obvious. You find the square root of 16, that's 4. The square root of minus 1 is I. So, alright. So this is actually x plus 4 equals plus or minus 4i. Now, you can get two solutions. And the first one, alright, so you do x plus 4 equals, let's do the plus 4i. And you do the minus, you get x plus 4 equals minus 4i. And you subtract 4, so you actually get minus 4 plus 4i. And then you do the same here, right? You subtract 4, and the other one is actually minus 4i. Now you can consolidate them in one answer, or you can just leave them like that, right? You have two answers, that's perfectly alright. But if you want to make them look nicer, it would be minus 4 plus or minus I. And either way, it's a good answer, right? So this is a good answer. Or you can leave the answer as 1 and 2 solutions. Either way. Alright, let's go to the next one before we do number 22. This is about the quadratic equation using the quadratic formula. Alright, so this will be x squared plus 3x rather. Oops. Let me go back. So x squared plus 3x minus 2 equals 0. Now what this one tells you is as follows. The coefficient of x squared is called a, because you can actually write this one as ax squared. The coefficient of x is called bx, and then the constant, which in this case is minus 2, we call it 0, right? This thing right here, this equation right here is called the standard form. And it's called the standard form because once you write it in this order, meaning the square first, then the number with x's, and then the constant, you automatically know what a is, b is, and c is. So alright, so this is written the standard form, meaning the squares first, then the x's, and then the constant. And right away you know a will be 1, b will be 3, and c will be minus 2. Right, the formula x equals minus b plus minus the square root b squared minus 4ac divided by 2a. And alright, so we are populating this. B is 3 minus b means actually the opposite of b. If b is 3, minus b will be minus 3. That's what we do, right? You just write b with the opposite sign. Now b squared, that's the first number going inside the radical. B squared is 9. That's easy to see because 3 is b. B squared will be 9. Alright, so 9. And then minus 4 times a. A in this case is 1. Alright, so times 1 times c, according to the formula, c will be minus 2. I'm going to just leave it like that, no parentheses. And alright, so all of that under the radical. On the bottom you have 2 times a. A is 1, right? So 2 times 1 will be 2. Let's go ahead and do 2. Now we do this number inside of the radical, and what I do, this is the way I do it. So I type it the way I see it. So 9 minus 4 times 1 times negative 2. In this case I do 2 and then change the sign to make it negative 2 and give you That's actually correct. Yeah, I was expecting something else, but that's the answer. Uh, so this gives you minus 3 plus minus, and then inside you have 17. So let's go to 17 divided by 2. And you can write this as two answers, right? Because one with a plus and another with a minus, but you can leave it like that, and that's a good answer. All right, that's 22. Let's go. We're gonna do two more. Actually, one more using the quadratic formula. This is 23, and this is the problem. 6x minus 1 times 2x plus 3 equals 5x. And we are using the quadratic formula to solve this equation. Now, this looks really weird, right? It doesn't look like a quadratic equation, but it is. Because see, on the left side you have 6x times 2x, so you will get an x squared, and then some x's, and then some numbers. But it is a quadratic equation written not in standard form. So we have to rewrite the equation into the standard form. Let's do that. So let's do the left side. 6x times 2x. Well, that's 2x, 12x squared. The outer will be 3 times 6x. That's 18x. Inner will be minus 1 times 2x. That's minus 2x. And then last, minus 1 times 3 gives you minus 3. And of course that will be equals to 5x. Let's simplify the left side. So the left side you had 12x squared, 18x minus 2x. That's 16x minus 3. And still this is equals to 5x. Now this is not the standard form, because the standard form looks like this: ax squared plus bx plus c equals to 0. So it has to be the x squared first, the x's next, the constant, and then equals to 0. So the 5x, this 5x, is definitely in the wrong place, right? Somehow you need to get rid of it, and we're going to get rid of it by subtracting 5x and subtracting 5x. So you do 12x squared, 16 minus 5 is 11x, and then minus 3. And on the right hand side, 5x minus 5x gives you nothing. And nothing, well, that's what we want. Nothing is actually 0, right? So this is the equation in standard form. Right away, you know a is 12, b is 11, and c is minus 3. That's the advantage of writing this in the standard form, right? Because you right away know b, a, and b, and c automatically. But all right, let's go to the next slide. This is 12x squared plus 11x minus 3 equals 0. And we're going to the next slide. So this is the problem. 12x squared plus 11x minus 3 equals to 0. And we know a will be 12, b will be 11, and c is minus 3. And we're using a quadratic formula, right? The quadratic formula, you don't have to memorize it. Minus b plus minus the square root of b squared minus 4ac, all of that inside of the radical. On the bottom you have 2a. So x equals, b is 11, right? So minus b, well, that's minus 11. That's kind of easy to see. And then b squared, that's the first thing inside of the radical. That would be 11 squared. 11 squared is easy, right? 11 times 11 is 121. Minus 4 times a is 12. Times c, which is minus 3. And then 2a on the bottom. 2 times a is 2 times 12, which is 24. Now the first thing we do is, well, let's do this first. Minus 11 plus minus the square root of the radical, or the thing inside of the radical. To find the thing inside of the radical, this is always what I do. Bring the calculator, and we are going to find, doesn't move. All right, clear. So you type whatever you see inside. So 121 minus 4 times 12 times negative 3. So to do negative 3, you do 3 and then change the sign of 3, and you get 265. I don't think it's a perfect square, but just to make sure you do square, definitely not square. So 265. And just give me a second. Let me just make sure of something. So we're gonna leave it like that because the square of 265 cannot be simplified. All right, let's go. I forgot about this one. I think it's 23. We're going to 24. In 24, this is a word problem. The problem is the sum of the squares of two consecutive integers let me write everything. Integers is 221. Find both numbers. Find the numbers. Now, all right, this requires a little bit of thought. This is the solution. And whenever you have a number, an integer, for example, 5, how do you find the next consecutive? Well, you basically do, of course it's 6, right? But how do you actually find it? Well, 5 plus 1 is 6. And then let's say you have 200. What's the next one? Of course it's 201, but how do you actually find it? You do 200 plus 1. All right, so 201. And then so on. Let's say you have minus 7. What's the next to minus 7? The next integer. Well, you add 1. Minus 7 plus 1 is minus 6. But we don't know what the numbers are. So, all right, so the first one is x. What's the next consecutive one? Is x plus 1. Why? Because you add 1 to get the next one. All right, that's kind of trivial, but it's essential for this problem. So the sum of the squares. So there are two consecutive ones, and then when we add, let's find the squares. One is x squared. That's easy, right? The next one was x plus 1, so you square that one too, and the sum of the two squares is 221. So what are they? You have to find x and then x plus 1. So let's do this problem. Oh, 220. I didn't mean to do that. This is 221. So let's go to the next. For logistical purposes, I need to erase every time, right? So this is the problem. The first one is x squared because the first number is x. Now the next integer will be the next one for x. And how do you find the next integer after x? Well, you do x plus 1. So x plus 1. So thus the sum of the squares gives you 221. All right, so we need to find x. And that's the first one. The next one will be plus 1, x plus 1, right? So we're going to find x and then x plus 1. But first you need to find x. So let's simplify this one, x squared. That's easy. So let's do x plus 1 squared. So x plus 1 squared is basically x plus 1 times x plus 1. So you do x times x, that's x squared. The outer will be 1x, the inner will be another x, last will be 1 times 1, so that's 1 equals 221. And all right, so let's simplify. X squared and x squared gives you 2x squared. X and x gives you 2x. And then plus 1 equals 221. But this is not in standard form, right? You need to subtract 221 because you need to leave it as equals to 0. 221 minus 221 equals 0. All right, so this is the equation. 2x squared plus 2x. And then you subtract 1 minus 221 gives you minus 220. But all right, and let's do, oops. Let's do the next step. So if you look at this equation, right, this equation is in the standard form. So A is 2, B is 2, and C is minus 220. So we're going to find this using the quadratic equation. B is 2, so minus B would be minus 2 plus minus square root. B squared, that will be the square root of 2, that's 4, minus 4 times A, which is 2 times C, which is minus 220. And then this will be 2 times 2, this is 4. Alright, so let's keep going. X equals minus 2 plus minus. Let's first find the thing inside of the radical, and the way I do it is this way. So you type everything you see it the way you see it inside the radical. 4 minus 4 times 2 times negative 220, so it's 220, change the sign, and you get 1,764, and you divide by 4. Now, if this has any solutions, the square root of 1764 has to be an integer. Let's go and find it. I just did it, but let's do it again. 1764 square root is 42. All right. So you have minus 2 plus minus 42 divided by 4. So let's find the x's. And I need to go to the next slide. Minus 2 plus minus 42. Minus 2 plus minus 42 divided by 4. Alright, so minus 2 plus minus 42 divided by 4. We are going to do, they're integers, right? And we're going to do the plus first. So it's minus 2 plus 42 divided by 4. Just the expression with the plus. So on top you got 42 minus 2, that's 40, divided by 4, well, that's 10. So one of the numbers is 10, and the next one will be 11, right? X and then x plus 1. So the answer will be 10 and 11. There's actually another solution. Let's see. Minus 2 minus 42. If we use the minus as well, so you get minus 44 divided by 4. You get minus 11. And what's the next one? Minus 11 plus 1 is minus 10. So the solutions are, there are actually two, 10 and 11, and then separately minus 11 minus 10. Now they look kind of weird, but an integer in the consecutive one is found by adding 1 to the first one, right? 10 and 10 plus 1, which is 10 and 11, and then minus 11 and minus 11 plus 1, which is minus 10. All right. So next one. All right. So I think this is a good place to stop. This is video number 2. Video 3 will be coming up very soon. All right.